Let's study multiple linear regression with two predictors. The equation will be y hat is equal to b naught plus b1 x1 plus b2 x2. Let's say this is the data set that we have. There are 5 points. These are the x1 and x2 values, and these are the y values. Now we'll compute the result using closed form formulae. So for that, first we'll need the means. So the mean of the feature x1 hat is equal to 1 upon n summation x1. Similarly, we'll calculate the mean of the feature x2, and we'll calculate the mean of y, the output variable. Now we'll define the centered values. So x1c is equal to x1 minus the mean of x1. x2c is the x2 minus the mean of x2, and yc is y minus the mean of y. Now let's compute these sums. We'll call them as S11, S22, S12, SY1, and SY2. So S11 is equal to summation x1c squared, and S22 is summation x2c squared. S12 is summation x1c multiplied by x2c, and SY1 is summation x1c multiplied by yc, and SY2 is summation x2c multiplied by yc. The denominator of all of them will be, let's say, d, which is equal to S11, S22 minus S12 squared. Then the coefficients will be given by this formulae. B1 is equal to SY1 S22 minus SY2 S12 divided by D. B2 is equal to SY2 S11 minus SY1 S12 divided by D. And the intercept will be given by B0 is equal to mean of Y minus B1 times mean of X1 minus B2 times mean of X2. Now let's actually calculate the numbers for this given example. So x1 mean is equal to 0 plus 1 plus 0 plus 1 plus 2 divided by 5 equal to 4 upon 5, which is 0.8. I recommend that you take a look at the given data, pause the video, and actually use the formula given to calculate these values, and then you can confirm your calculations with what I'm doing over here. Similarly, we calculate x2 mean and y mean. Then we create a centered table using fractions to keep it exact. So instead of actually calculating decimal places, we'll keep the fractions as it is. And these are the different x1c, x2c, and yc values for the 5 data points. The next step is we have to calculate the sums. So the sums S11 is summation x1c squared. That means we'll have to square each one of these values that we have found in this table. Okay, so each one of them has a denominator of 5. So we can take divided by 25 as common. And the numerator, so first one is 4, so 16. 1, then another 4 squared to 16, 1 squared to 1, and 6 squared to 36. And therefore, S11 will be 70 by 25 or 14 by 5 or 2.8. S22 will be summation x2c squared. Similarly, you can see the column of x2c over here. Again, all of them have the denominator 5, so the denominator, because you're squaring it, so denominator will be 25, and numerator will be 3 square is 9 plus 9 plus 4 plus 4 plus 4. So this is 30 by 25 or 6 by 5 or 1.2. Similarly, we'll calculate S12 is x1c multiplied by x2c. We'll have to calculate that. So 4 into 3 into 1 into 3 into 4 into 2 into 1 into 2 into 6 into 2. So adding all these, also we'll have to take care of the sign. So for the first data point is minus 4 into minus 3, so plus 12. For the second data point, it is 1 into minus 3, so it is minus 3. For the third data point, it is minus 4 into 2, so minus 8. For the fourth data point, it is 1 into 2, that is 2. Or the fifth data point, it is 6 into 2, that is 12. And we add all these values, so therefore we get the numerator as 15. Okay, and finally the result is 3 by 5. We can keep it as it is or reduce it further to 0.6. sy1, similarly, we'll calculate the product of all the x1c and yc values. And by doing that, we'll get the sy1 similarly as 115 divided by 25 or 23 by 5, or we can simplify it further to 4.6. And sy2 will be summation x2c multiplied by yc. So again, we'll take a look at the columns that we had calculated in this table. We'll multiply x2c with yc values on each row, and then we'll add all those products. So we'll get 24 plus 9 minus 6 plus 4 plus 24 divided by 25, which is 55 by 25, which is 11 by 5, which is 2.2. The formula for denominator. So denominator can now be calculated as S11 into S22 minus S12 squared. So it is 14 by 5 into 6 by 5 minus 3 by 5 square, which is 84 by 25 minus 9 by 25, which is 75 by 25, which is 3. So now we can calculate B1 and B2. So B1 is nothing but SY1 S22 minus SY2 S12 divided by D. So we'll substitute the values that we have found above, and it will simplify to 7 by 5, which is 1.4. B2 is SY2 into S11 minus SY1 into S12 divided by D. We'll substitute the values we calculated above, and it comes roughly to 17.15, which is roughly 1.1333. I highly encourage you to calculate this on your own and verify the answers. Now to calculate B naught, it is mean of y minus B1 times mean of x1 minus B2 times mean of x2. So 13 by 5 minus 7 by 5 into 4 by 5 minus 17 by 15 into 3 by 5. This simplifies to 4 by 5, which is 0.8. And therefore we have the final equation y hat is equal to 0.8 plus 1.4 x1 plus 1.13333 x2. Now we can also say it in fraction form as it is 4 by 5 plus 7 by 5 x1 plus 17 by 15 x2. So the point of showing all this was, in the previous video we had derived the equation for the one independent variable, right? Y was a function of only one variable x, right? There was only one predictor x. In this case, we have taken the example there are two predictors x1, x2, and we already have different closed form formulae for the coefficients b0, b1, and b2. If we take three predictors or three independent variables, so the output or the dependent or outcome variable y as a function of the independent variables, let's say x1, x2, x3, or the predictor variables x1, x2, x3, then we'll again have a different set of formulae, closed form formulae for b0, b1, b2, b3. Is it sustainable? It is feasible? Is it computationally good? Because in real life, we can have hundreds of features, and every time we cannot perform, we cannot, it's not very efficient to have different formulae for different number of variables, different number of predictors, right? So in the upcoming videos now, we'll study some techniques to solve linear regression, and we'll try to find out an equation or use an equation which will remain the same irrespective of the number of predictor variables or number of independent variables. So stay tuned.